from the waiting room. All right. Thank you for everyone who's joining us so far. Welcome to the June event, the Our Ladies Philly June event. I'm Alice. I'm one of the organizers of the Our Ladies Philly team. And today I'm just going to do a brief introduction about our group and make a couple announcements, and then I'll get right into the agenda. So, okay. First, for anybody who's joining an Our Ladies event for the first time, just to reiterate, what is Our Ladies? It's a global organization with chapters all over the globe. And our chapter has been in existence for about 2 years. We have over 50 events that we've held, free events for the community, focused on promoting gender diversity in our community. And I have a few announcements that I want to make. First, I want to start off by pointing to the recent statement that was made jointly between Our Ladies Global and Forwards on Black Lives Matter. And it's important that we want to say we lend our support to this. We think Black Lives Matter. We want to be supporting and acknowledging this movement and racial injustice in America, and also acknowledging the compound effects of intersectionality when people are members of multiple underrepresented groups. And so there's a couple things that you can do. You can click on this link to read the statement that was authored by members of both groups. And we've also created a feedback form. So we want to hear from you, our members, what we can do for our local group to support the Philadelphia community, how we can advocate for and support Black members of our community. And so if you want to reach out to us, you can email the organizers, or you can fill out this form that we have soliciting feedback. Another thing that we have now is a new effort is a mentorship or speaker directory. So I've put the link as well there, ourladiesphilly.shinyapps link. And that's a place where you can sign up if you're interested in being a mentor or a speaker at a future event. And you can also find people if you're interested in additional mentorship opportunities. Next announcement is some of the upcoming events that we'd like to highlight. One is from the Data Philly group, which is one of the other local data science community groups in Philadelphia. And they have an event coming up which will feature R and some different analyses that can be performed in R. And so that's coming up on Wednesday, June 17th. We have a July event that you can find on our meetup page coming up in July, and an August event, which are already posted on the meetup. The other announcement I want to mention is that we are recording this meetup, and it will be posted hopefully shortly on our YouTube channel, which is a new thing we're doing now that we're virtual. All right, now I want to get right into the agenda. And so today's meetup is a really exciting one, I think, or I personally am really excited about this meetup because we have two great things coming. So first, I'm going to pass to Jinyi Kuang, who's going to give a lightning talk on R packages to add to your workflow. So this is actually, I hope, something that will get you excited about all the cool things that you can do in R if you're coming to R as a complete beginner. It's also an opportunity to highlight some of the really interesting work that we're doing around in this local area. I put here some of the links to the materials for today from Tess and from Jinyi, and we'll post these again in the chat as well to make it easy to find these, and we'll kind of keep reposting them. If you have any questions during the talks, we do have everybody on mute, but if you need to ask a question, you can post it in the chat, and then we'll be able to relay it to the speaker. I think that's all the major announcements for now, so I'm going to stop sharing my screen and do a brief introduction for Jinyi, and she can start sharing her slides as well. So Jinyi Kuang is a research specialist at the School for Social Norms and Behavioral Dynamics, and she is also a Ph.D. student in psychology at the University of Pennsylvania. So we're really glad to have her here to present this lightning talk. Her research focuses on how people's social beliefs and expectations impact behaviors, which is an extremely relevant and important topic. So with that, Jinyi, do you want to see if you can start screen sharing?
Sure. Thanks, Alice. I'm just going to share my screen right now. Okay. Can everybody see it? I'm going to do...
Yes,
okay.
I can see it.
Okay, perfect. Hi, everyone. My name is Jinyi. I'm a research specialist at the Center of Social Norms and Behavior Dynamics. So today, I would like to share with you about some research that our team has been working on and share about some R packages that I have used in our data management, analysis, and visualization. I think those packages are really neat and actually reducing the number of code that I have written. I think those packages are also very user-friendly, especially for those who are pretty new to R, and also could be a good asset for those who has been using R for a while. I hope those packages could also be very useful for your workflow. So first, I would like to briefly introduce what kind of research our team has been working on. So our teams has been very interested in understanding how social norms and social networks influence behavior in a collective level. So what does it mean by collective behaviors? I think it could be a customs. For example, when it's raining, everybody's using the umbrella. Or it could be a social norms, such as social distancing. Like most of the people practicing social distancing right now, and most of us believe that it is the right thing to do. So this is like a social norms. There's a clear expectations about what people do and what people think it is the proper way to do. So our teams bring out our research out of the labs and into the field, and collaborating some local with local and international organizations such as UNICEF, Gates Foundation, or World Bank to understand the drivers or the motivations behind those collective behaviors. In the past 3 years, our team has been working in India to understand the social factors related to people's sanitation behaviors. One might ask why this is important. I think sometimes when we're living in the States, we often like neglect or taking granted for the great sanitation conditions we have here. But in India, this is a different story. About like 600 million people who suffer from the indignity of defecating in the opens. When in every 10 deaths in India is linked to poor sanitations. And also girls and women, they have to go to the field before sunrise or after sunset to defecate, which leave them very vulnerable to sexual harassment. So those are so many factors were contributing to this collective problems, and it's actually very complex. But our team is just like taking a look at the tip of the iceberg. We're interested in understanding what is the social factors related to the sanitation problem in India. So our team has designing the cross-sectional survey to trying to diagnose what is the nature of this collective behavior. Is it like a social norms, or it is just a convention or customs? So the data we have been working on is relatively about medium size. So we have about more than 5,000 people participating in our survey, and we have implemented the survey in 2 states of India. So today, I'm just want to share with you my experience working with this data set using R. So this is like a brief overview of our research. And now I kind of want to just like jump into R and kind of show you some packages that I really recommend to add to your workflow. So the first and foremost one is Tidyverse family. I think like everybody's really appreciated this R packages from importing data or from the data, like manipulating data structures to visualization such as ggplot2, and also you can communicating with K-nears, writing Markdown and producing those very nice reports. And Tess will give a more comprehensive introduction to Tidyverse, so I won't like speaking too much here. Coming up next, I think this package is called EXPSS, which have really nice label support features. So some of our team members using SPSS, the data, the data set is in SAV format. So the EXPSS create the format into R. And then I found those two functions are very helpful. One is called VerLab, and the other one is WellLab. So the VerLab is like looking at what is the label of this variable, and Value Lab is looking at what is the value label of this variable. Especially like when you're working on a very relatively larger data set, there's so many variables. So usually people are using those like a numerical coding system. It might not be very intuitive to know like what is the meaning of this variable. So I think this package is very useful to help us like, to spot check if we're not like analyzing on the wrong variables that we're doing. Coming up next is the package is called Open XLSX. So I think this is a really comprehensive package to use with EXPSS because you could actually save your output from R to an Excel file. Especially in a team, not everybody might be able to, might be interested in using R. So like, it's really nice to share your output with your team members. So this is just like a Brave code example, like how this thing works. It also like using the same grammar as tidyverse, such as like here's the pop, or like here, like you can just without equals for your variables, you could just like selecting by the variable name. So this code is demonstrating that I want to know what is the percentage of gender and education broken down by state, and then I can, add in a caption for my tables. And here is the code showing that I can creating Excel workbooks and then adding a name of this sheet. And then I can write the table that I created in R into that Excel workbook. And then I would be able to save it. I think this is a very useful package. It's relatively intuitive to read without like you have to make a lot of comments for your code. Coming up next is the library is called Stargazer. I think a lot of people probably have heard of this package, which is very popular among our users, especially when you're doing some, for example, regression analysis. This package is very useful to producing this publishable tables for your analysis result. So this is just like a snapshot of what is the output using this package. And next one, we have some recommendations about the package you're using for visualizations. So on top of ggplot2, which is part of Tidyverse family, I think those two packages, one is called ggthemes and the other one is called Plotly. Those two packages are very useful as well. So for ggthemes, it has some extra gem, extra scales and themes on top of ggplot2, which can add more, make your graph looks nicer. So this is a graph that I have made for our research, which is showing the distribution of the perceived behavior prevalence. For the Plotly, I think the great feature for Plotly is that it can creating this interactive ggplot2 graph. So actually you can, when you're making change, you can have this like interactive view of your changes in the code. And there's also a great cheat sheet for Plotly. So like you get a lot of like, functions for free. Like you can just like modify, for example, just change the variable in the function that they wrote in the cheat sheet. I think it's very useful as well. So the last package I would really like to recommend is called Map View. I think this package is particularly helpful for those who are interested in manipulating a shapefile, which is like, you know, for example, plotting in a real map, plotting your data points in the real map. So I'm gonna show a little bit demo here. So this package is called SF. So using this package, you can read the shapefile that you find from internet. So here I'm finding this shapefile from Indian Census 2011, and this is by district level census file, shapefile. And then I'm reading that into as SF object, and then I'm selecting the district that I'm interested in, Pudukkottai and Kunur, which is our intervention district. And then I'm saving that as a SF object, which is called district. Then I'm calling this map view function. So I'm giving it the district, which is the object I created previously. And then I specify that I want to view those two districts in the gray colors. So this is a border of the color, and this is a region of those two districts. And then I'm giving this layer a name. The great of this function is that it creating those like interactive map view. For example, I can zoom in or zoom out. I can drag and drop. Also, I can change the background map. For example, here I can do this open straight maps, which has more features that you could see. If you're plotting data, for example, from US, you could have a better visualization because I think it has better like features in the US-based map. Also, you can just remove this feature or add it on. There's multiple different maps on the backgrounds. So here's an example how you can integrate this map view functions with your own data points. For example, here I have this Excel file, which is called the Word Excel. I have 3 columns. The first column is longitude, and the second column is latitude of the word or community or village. And then the other column I have is if it's a treatment word or if it is a control word, because like this year we're gonna do random control trial. So I want to visualize the different words on the map, especially like on overlay of the region map that I have just created. So I can just using the plus sign here, just overlay different layers of data on the same map. So here I'm using the Open XLSX packages, and it has a function called read XLSX. And then I'm converting this object, which is Excel object, into a SF object, which is the shapefile. So I will specify the coordinates, like which column I want it to be longitude and which column I want it to be latitude. And then I give this object into this function. Here, the Z column means which column I want to looking at. I want to color by treatments. So for the control village, I want to give a darker shade of gray. And for treatment village, I want to give a lighter shade of grays. And then I'm also giving this layer a name, which is called treatment and control words. And I also want to use the same color for my legend, so people won't get confused what those colors corresponding to. And then specify what is the size of the dot that I want those village to be on my map. So now you can see this is interactive result out of those functions. The same as here, that you could zoom in and zoom out, have a better visualization of those villages. And also you can change to, for example, I'm remove 1 layers or adding 1 more layers. You can also take in a screenshot. There's a function in the map view package, which is called map shot. And then you can save that as a PNG file. So I think it's a very neat package and is very easy to use. Yeah, just to sum up, these are 6 packages I think is very useful to add to your workflow. Actually, I hope that will be helpful to help you to start to learn R and give you more motivations to actually do it. I just want to share a little bit of my story. When I first joined the teams, I don't know anything about R, so I basically more like a self-taught like programmer, well, quote unquote programmer. And then I found that start learning tidyverse and then like kind of like, just learning by doing, making mistakes, actually get your hands dirty in the code really is really helpful for me to getting used to using R. And now I feel like I'm very exciting to explore new packages or using R to do different things, such as like writing this presentation with R Markdown. So I feel it really gave me the sense of accomplishment. So this is all of my lightning talk, and I hope you all enjoy learning R and stay connected.
Yay. Thank you, Jinyi. Thank
Yeah.
you. I think if we could all give a virtual quiet round of applause, virtual round of applause, it would be booming if you could hear it. Thanks for sharing. And as you mentioned, people can follow you around on Twitter or email you, and we'll be posting, again, the link to your slides. And so people can refer back to them. Thank you again.
Thanks for inviting me. It's a pleasure to share those R packages.
Awesome. And I think if we have questions at the end as well, if we have time, we can address them. Right now, I think it's a good idea to start to transition to Tess. If Tess, you could start to share your screen and I can do an introduction. Okay, so I want to give a big welcome to Tess Cherlin. So Tess is a PhD student at Thomas Jefferson University in the Genetics, Genomics, and Cancer Biology program. And she does research in the Computational Medicine Center. And she shared a little bit of her story that, like Jinyi, she had no experience with R coding when she began her PhD, but she has found R very learnable and useful for data analysis. So thank you again, Tess. Welcome. And I will hand the floor to you. Tess, you're on mute. I can't hear you.
Yep. Thank you. I was asking if you can see me because I just turned on my camera, but I can't see it on my actual screen.
We can see you, yeah.
Okay, cool. Hello, everybody. As Alice said, I'm Tess, and I don't actually have to do much of an introduction now. She said basically everything. So, just a teeny piece of background or introduction is that I do both wet lab research and I do computational research. And so half of my days, not my days specifically, are in the research lab and pipetting and looking at cells, and the other half is coding. And I learned all of that in the last 5 years. So it's been very fun. And so I'm not going to talk about my career because we're going to get into the actual research. It's really weird this is my first actual talk over Zoom, so please bear with me. So I wanted to just reiterate what Alice said earlier and take a moment to recognize those who have died at the hands of racism and police violence. So I really appreciated the R Ladies statement of solidarity with the Black Lives Matter movement, and which Alice covered earlier, and I'm posting up here for everyone to read. In an effort to increase my personal understanding of the representation in the STEM fields, especially computer science, I thought today we could use data sets from the Women, Minorities, and Persons with Disabilities in Science and Engineering 2019 report. And specifically, by the end of today, we're going to make bar graphs looking at the different careers that in STEM that men and women, or females and males, actually hold in STEM fields, and then also the different ethnicities and races that are stratified. So different computer science jobs held by females and males in these different ethnicities and races. And so it's, for me personally, it was really eye-opening to look at these data sets. I've heard there's disparities on gender and race and ethnicity, but I thought it would be helpful to all learn a little bit more from this report. So the goal today is to become familiar and comfortable with the basics in R in order to pursue future learning and develop a greater appreciation of the disparities in STEM careers, especially computer science. And our objectives will be to provide a brief introduction of R in RStudio, become familiar with the RStudio environment, learn how to open R code and read in data files into RStudio, learn how to manipulate data and write data in RStudio, calculate basic statistics, and create and save bar plots in RStudio. And so yeah, this is very basic. If these things are familiar to you, feel free to stick around or not. Maybe you could provide insights to other, to newer people learning R for the first time. And so a little background of R in RStudio, very brief. R is a language and environment for statistical computing and graphics, and RStudio is an integrated development, basically a interface or environment for the R language to actually be run. And the reason that I started using it personally, and maybe a lot of other people, is because it's free and open source. And so a lot of academic people actually use R for this reason. So R for beginners. This session is going to be very hands-on and hopefully fun. It's not going to be perfect or exhaustive at any means, and mostly because I don't know everything. So everything our last speaker talked about was really cool and amazing, but none of what she does is anything I do at all, because I look at cancer expression and she's looking at social behaviors, and that's awesome. But it's cool that R can be used in those different ways, but sometimes the tools are different in R. So there are many ways to do everything, and when in doubt, I just Google how do I blank in R, and maybe there's other ways to do that as well. So let's get started. Step one. So I want everybody to, if you haven't already, to download the files from GitHub, and they should be in the chat. And maybe you can just post them again in the chat real quick so everybody can get to there. And I'm trying to find, okay, lost the chat. Okay, and so everyone download those files, and then you don't have to put them into your desktop, but for the ease of following along, it might be best to, once you download the files, it's going to be, oh, I'll show you what it should look like. So if you go to the GitHub thing, and then you can go here and download as a zip. And when it downloads, depending on if you're in a Mac or PC, it might look a little different, obviously, but it's going to look like this as a zip file, and then just double click it and you'll have a folder, and depending on whatever your operating system is, just move that folder to your desktop. And that's just so we can all be on the same page moving forward. And okay, I think so when you open that, you should have 2 Excel files and 3 R code or R scripts. And I really wish I could see my face, because this is really creepy looking, but there's nothing there and you're just all there somewhere, but that's okay. Okay, so the next thing on the agenda is to open RStudio. So everyone should have in advance downloaded RStudio, and RStudio is, if you have it installed already, you should have a RStudio circle at the bottom of your screen here. If not, you can go, I believe, to application, somewhere in your applications, find it and double click it, and it should open up on your screen. So when you do that, you should get something that looks kind of similar to this. And this is the RStudio interface. And I'm not looking at the chat at all right now. So if you have questions or if you're lost, please put your questions in the chat, and any of the wonderful experts, our experts, can help you. um, this is the RStudio interface, as I said, and we're going to be working in here in a minute, but I just want to make sure everybody's on the same page before we get started. Why? Oh, okay. Sorry about that. Okay, so the first thing we want to do, and that's the next step
That's
on our,
one
yeah.
question did come up in the chat, is if you could show again how you download the files from GitHub, just real quick again.
Great question. Okay, so hopefully the link takes you here. So it's all day scientist, it's /R ladies. And once you go there, you'll have these 3, 4, 5 files, and you can go to clone or download and download zip. And that shall download to your downloads folder on your computer. And so I guess it'll be easiest moving forward if at any point I'm going too fast, can you just, someone type that into chat and then someone tell me, and I'll stop and slow down, because
Perfect.
no way to get any sort of feedback right now. So I appreciate that. Okay, so I'm gonna go back to the RStudio interface, and the first thing we want to do is basically connect ourselves to where those files are. So to do that in R, we need to find our working directory. So if you see on the bottom left, right now your screen might look like this, and it'll change once we start bringing in files, but I'm just going to keep it down here. So right now we don't know where this RStudio actually is, where all the files are in them. So we're going to do what's called get our working directory. So that's the first function you're going to use in R, and it's GET. So everyone should type this into their console in the RStudio bottom section. And then this these parentheses, GETWD and parentheses. And this is going to tell us where we are on our computer. And so for me, I'm in this spot, but that's not actually the right spot. This is an old folder. You might be somewhere completely different. We want to go to our desktop, which is where we moved the folder of those files. And so to do that, we're going to employ our second R function, which is set working directory. So set WD. And if you see here, we have when it outputted the working directory, you can see that it's in quotes. So we want to always include quotes when we're setting our working directory. And so for me, it's going to be users txc065. Yours might be your first and last name or whatever. And then desktop. And then you can press the tab. So all I did here was press tab. And it brings up all the different folders on my desktop. And so I want to find the R Ladies folder. And so now, and you press enter. And now when I press get working directory, it's moved me into this new directory or new folder. And once we're here, we can go over to the files section on this bottom right panel and go to this little wheel that says more, and click this thing that says go to working directory. And that's going to bring up all the files just so you can see them. Just something to see and look at. So that's all shown here. So on a Mac, it's going to be set working directory like I showed you. Oh, that should be a backslash, sorry. And then on the PC, it's going to be the C:\\. And that should be good to go. Okay, I'm going to move on unless anybody is still at this spot. So if you are, please add that to the chat, and if not, I'm going to move on to the next thing. Okay. So the next thing we're going to do is learn some basic commands in R and learn to assign values to variables and discover types of data. So in order to do that, we're going to open our first R script in R. And to open our first R script, you're going to go to this little open an existing file foldery thing on the top left here. Click that. And because you're in the directory already, it's just going to have only the things that you want in this folder. So we're going to use the R Ladies for Beginners intro script, and you're just going to press open, and it's going to open up your first R script to look at. And so the first thing you might notice in this script, if you've never seen an R script before, is that you have different color things, because our eyes immediately just look at colors, and the stuff in green is all preceded by a hashtag or pound sign. And those are R's way of telling us that this is a comment in R, and when the R script runs, if you're going to run this program or script, it won't run anything that's commented. That's just for you as the user to look at and read for your personal use. Okay, so the top thing says this is the R for Beginners intro.R. .R indicates that it's an R script, and so the R Studio can actually read that. And in this section, we're going to learn some basic commands and functions, learn to assign values to variables, and discover types of data. So we're already in our working directory, so we can skip this part. And I'm going to switch back over real quick to talk about different types of data and variables, and then we'll come back and actually do the actual coding. Okay, so there's different, that's not what I want to say. So let's see, what do I want to say here? So in R, there's different types of data, and you can have, so let's pretend that say is data. And so you have different things called, integers, characters, strings, floats, and booleans. So what we're going to be using mostly today are integers or numerics, and those are just numbers. The characters will be letters, and then strings are a collection of either letters, numbers, or letters and numbers, just all together, like a sentence or something. And we're not going to today worry about the floats or booleans too much. We will use decimals, but we're not going to need to pay attention to that specifically today. So the next thing I want to tell you about are variables. R is everything I need to do in R requires variables, and that is basically when you assign something to something else. So here, my variable equals the number 10. And something that's really important to remember in R is that you can write over a variable. So you have to be careful, because if we now change my variable to the word panda, it is going to replace the 10 with panda. So just keep that in mind. So yeah, a variable can be reassigned in R. So I'm going to talk about 3 different data types. The first is a vector. A vector is a group of data values. So we have a group of numbers. It's a one-dimensional group of data values. So just like a vector in math, a vector in our language is a group of numbers or a group of words or a combination, but those are vectors. We also have matrices, which is a matrix is a 2-dimensional vector. So you have that vector from before, but you also have more vectors adding onto each other, and that can make a matrix. The important thing to remember, which you don't worry about it, we're actually not going to be working with vectors today. Matrices today, is that matrices can only hold one data type at a time. So it can either hold all numbers or all characters are all strings, but it can't hold multiple things at once. However, with a data frame, you can actually include multiple types of data. So in this data frame, it basically just looks like a mini Excel spreadsheet where you have column 1, which is the names, column 2, which are ages, and column 3, which is number of donuts we like to eat. And I don't know in what span of time, but apparently I like eating lots of donuts, which is true. So the important thing to remember about data frames is, which I'll remind you in like 5 minutes, is that you call data usually by the column, and it includes a $sign, which we'll get to in a moment. And the last thing I want to say is that just something to keep in mind conceptually is that we have all these different types of data. Those data can all be stored in variables, which I just explained a little bit. And then the really cool thing about R is that you can then take those variables and use functions to manipulate that data. So the variables store the data, and then the functions do things with that data. And that's what our last speaker was talking about, all those wonderful packages and functions that can be used in R to manipulate our data into ways that we'd like to manipulate them. So let's go back to the R interface. So we're going to work through some introductory items. The first is that R is basically can just act like a calculator. So if you highlight 4 + 4 here and then press this run button, R is going to add 4 to 4 and give you the number 8. And it can do all sorts of math. So it can multiply, it can divide, and do, powers, and it does it all in order of operations. So that's just doing straight up regular math with R. We can also assign values to variables like I was talking about. So the first, my var1, if you copy and paste this, or even I'll just type it in actually. So my var1 equals the number 10. And if you just follow along with what I'm doing, it should work the same. And if not, please contact someone for help. So you can see this is the first time that we'll see something pop up in our global environment on the top right here. So when you just display a number like the number 10, you're just basically printing that number to R. But if you want to store that number, you need to give it to a variable, and that's what my var1 is doing here. Now let's just make a bunch of different variables. So we can do my var2 equals 15, my var3 equals 2, and my var4 equals C. Oh yeah, so those are 3 variables. And now we want to make an actual vector. So that's what I'm going to be showing you to do here. This is a function called concatenate, and it's represented by the letter C. And so we can concatenate these 3 numbers together, and it'll display them together. And if we want to store them as a variable, my var4, then you can see over here in our global environment that we have a vector of numbers 10, 15, and 2. So now we have our 4 variables. And to print a variable, all you do is type it into R. So you can either type them all in, or the nice thing about having a script is that you just highlight them and you can press run, and it'll print out all of your variables in order, in sequential order. And it's not just that you do math with numbers and then assign them to variables. You can actually do math with your variables. So we can add my var1 to my var2, and you get 25. And you can add you can do some other math. My var 2 plus my var 3, and it'll give you what my var 1 divided by 2. Okay, Carla is saying something really important, which is I'm using an equal sign all the time. You can also use the arrow sign. And so maybe you'll see both of those things. And I don't know if one is better than the other. If it is, please share that information. And you can multiply. Okay. Okay, so as I showed you before, you can overwrite a variable. So we have my var1 equals, if we want to have it equal panda, instead of 10, we can have it equal panda. And then again, if we print our variables, it's gonna overwrite that 10 with panda, and you can see in the global environment it's changed, and you have 15 and 2. So like we combined those 5 numbers and concatenated them into a vector, you can also do that with variables and concatenate them into a vector. So I can do that by doing C, my var1, my var2, my var3, and it's going to concatenate them. But as you can see, I can't call that information up. I need to store it in a variable if I want to ever use that variable, that vector. So to do that, we'll do new var equals C, my var1, 2, and 3. And now we have over here in our global environment, new var, which is a vector including panda, 15, and 2. And as you can see, before the vector was a list, it was a bunch of numbers, and now it has characters as the indicator of this vector because it includes at least one item with characters in it. Okay, so now we have new var displayed to our console. So I keep telling you these are vectors, and they are, but what if, what if I'm wrong? I could be wrong. So in order to find out if our data set that we're looking at is a vector, we can use this function is.vector. I'll type that in here, is.vector new var. So we want to know, is this data set a vector? And it's going to either tell us true or false. So in this case, it is true. Now we already talked about matrices and data frames, so we can just see if it's also one of these data sets, data types. So is.matrix new var false. Good. It's not a matrix because, it's not. And we knew that, but it's good to have a sanity check. And data, is this a data frame? Oh, and this is a good point. You might think that I'm moving really fast and can type really fast. If you ever want to go back to something you did before, you just press the up arrow. I'm sorry, I haven't said that sooner. So if you just keep pressing the up arrow, you'll scroll through all of the things you did previously. And I guess it's a good time to tell you that you can also go into your history and look up all the different commands in order that you did, and you can display those to the console and just press enter and do that again. So there's lots of different ways to call up previous commands. And so the last thing I'll do here is is.matrix, is.data frame new var false. Okay, so this is just a vector, and that's good. Okay, the last 2 things I want to tell you, and then we're going to move on. The first part is if you ever want to know how something works in R, you can use the function help. So all of those cool packages or functions that our last speaker was talking about, but I'll just use some, you could use the help function on. But here there's some examples, and so I'll just do bar plot because that's something that we're going to be looking at later. So when you do that in this help display, and you can also just type it in here, it'll bring up a manual of the bar plot function. And so it'll tell you like what every single little detail means in bar plot. But that's just food for thought. You don't have to worry about it right now. And the last thing I want to reiterate, something that our last speaker was talking about, is that if you ever want to add a new package to R, you can do two simple steps. We're not going to do this today, so that's why it's commented out. We're just using base functions today, but if you want to install a new package, you just type install.packages, parentheses, quotes, package the package you want to install. And then you have to, as you might have seen previously in the last speaker's presentation, then you type in the function library and then that package which you want to install. So that's what you would do if you wanted to like install ggplot, for example. You would do install.packages ggplot in quotes, and then library ggplot, and that library is storing it in your R library with the other functions that are already there. Okay, I'm going to move on. I think we're probably okay, but if not, please say so, because we'll move on to step 3. So in step 3, we're going to use the second of the 3 R scripts. We're going to learn to read in a CSV file from the RStudio environment and assign it to a variable, which you know how to assign things to variables now, so we'll be good. We're going to analyze data in RStudio, calculate some statistics on data in RStudio, and write your first files from RStudio to your folder or your desktop. So before we even go back to R, we need to do a very important thing, because R can't read in the most basic form, R can't read in Excel files. So we have these 2 Excel files in our folder, and we need to change them to CSV files. So on your, in your own computer, in your own space, open them up. And I'm doing this just so you know, and like we'll remember that you have to save them as CSV files, because you'll end up being like, oh my gosh, why can't I open this in R? Yes, unless you use the fancy packages. I know, I was amazed when I saw that. I was like, what have I been doing? So when you open your file, and you need to do this on both files, you're going to save as, and then to the same folder that you're in, to CSV. And so you'll save that one. And I don't know why my computer always tells me this weird error thingy, but it's working. And then you'll do it for both of them. So okay, so now in my Our Ladies -master folder, we have the CS_demographics, which is now a CSV, and you can see that here where it says kind, and also the STEM careers female male file, which is also a CSV. And that means that R needs to read it in. Oh, bye, Cliff. Nice to see you. And we, when R reads in these files, it reads them with commas, and it needs to see them with commas unless you use the cool packages. So I'm going to move on to open these. If anyone is still in the saving process, speak up. But I'm going to open up our next script. So back here again in the open an existing file, we're going to look at our data analysis in R. So open that up. And it's going to look very similar to what you saw before. We already have our working directory set, so we don't actually have to do that this time. So in this section, we're going to learn how to read in the CSV files, analyze the data, calculate some statistics, and write files from our studio to the desktop. So first things first, we're going to learn a new function, and that's called read.csv. Read.csv takes a CSV file from your desktop. Remember, again, anything that you're like bringing in, you need to put in quotes. So I'll type this out, read.csv. And if you press the tab on your screen, it's going to give you options of things you can put in those quotes. So I want to do the STEM careers female male file. Okay, and then you need to press a comma. So why do we need to press a comma? So the function requires at least one argument to work, and the first argument is the file that you're bringing in. The second argument we're going to do just for sanity so that we know that it's doing what we want it to do. We're going to tell R that our file has row names. So you type in the argument row.names, and that's our first column. So the first column, and if you look at this, the first column in this file are our row names. So we're just going to assign that. And then the header, which is really the column names, it can be either true or false. And so we're going to say that it's true. And there's some other arguments you could include, but this is basically the most essential ones. And so when you do that and press enter, you'll see your row names, and you'll see the females and the number of people, and the males and the number of people in those career paths. And so you'll probably remember that this is great, but if I look at my global environment, I don't see this data set here, and that's because we did not save it to a variable. So to save it, so press the up arrow so you don't have to type that over again. To save it to a variable, you can just assign it to whatever variable you want. Here, I'm going to assign it to the variable data. So now you can see in our global environment, we have a variable data. And if you click on it, you can see some information about it, that there are 7 observations, and those are our rows, and 2 variables, and those are the females and males, and they're all integers, and that's what you see here. Okay, and if you want to call it, like print it out like we had done before, you just highlight that and press print, which is just exactly the same thing here. So we just finished 3.1, great, go us. We read in the data. And that, for me personally, was a huge hang up when I was first starting in R. I was like, how do I get the data from my computer into R? What do I do? How do I do this? And how do I do it in a way that I can then look at it? So I hope that was helpful, because it took me a while to figure that out. All right, so now we're going to analyze this data. And the first thing and the easiest thing we can do is use this function called dim. And Carla put a helpful comment in there. You can double click on the data variable too if you just want to look at the data set without printing it to the console. Very helpful. So yes, if you want to look at your data, you can double click it, and you can see this light blue shows that these are the row names and not actually part of your data set. And then these are our columns, and these are so the 2 variables. And then another way of doing that, if you want to learn a new function, is you can use the function view on data, and it'll do the same thing. So actually, it's not going to show up because, so if you do that, it does the same thing as double clicking. So thank you very much, Carla. Appreciate that. But then you'll see that a new little thing popped up. So now you have to go back to your script over here. Okay. All right. So the next function we're going to be using is dim, which is basically just showing us the dimensions of our data. This is a small data set, and as you saw in the global, I'm pointing, you can't see where I'm pointing, but as I saw in the global environment, you have 7 rows. The left part of the dim is always the rows, and the right part is always the columns. So you can see that you have 7 rows and 2 columns. And if you want to check what the row names are, you type in row names data, and you can see that these are the different STEM careers. And if you want to see the call names of the data, you can see that you have males and females. So that's just the basics. And now we want to know what our data type is. So I guess I can try to see if this is a vector, and I'm assuming all of you are going to say, no, Tess, this is definitely not a vector, because I was paying attention and I know this is not a one-dimensional entity. And so, of course, it's not a vector because it has different dimensions. So is it a matrix? Well, we'll just go ahead and say, is it a data frame? Because it is. Well, I'll see. No, it's not a matrix. And that's because it had, well, that's just the way we read it in. And I don't know 100%, but I think it's because of, I don't know why it's, I have to assign it to be a matrix. Is it, please correct me if I'm wrong, is it because I read it in as a CSV that it's not a matrix? Please say yay or nay if that is the truth. We'll just say that's that for now, but I'm happy to be corrected. So is data frame data true? So now we know this is a data frame. And once we know that it's a data frame, we can use the $sign I was talking about. So data dot $, and we have two options. We have female and male. So if we want to look at just the female information, we can see that this is the number of people for each STEM career for the females. And if we want to see it for the male information, you have that displayed. Okay. Okay, so I've had a very, very important question posed to me recently, and I thought this would be a great time to address it, which is, so when we look at the data, we see that there's different numbers, and I don't really know which STEM path, career path, has the most people in that field. So I might want to order or sort my data. And there's many different ways to do this in R, but the most basic version is using the function order. And so I'll just type it in here. And, you know, I'm not going to get into like the nitty gritty details, but this will be helpful for people that want to sort their data in a, you know, moving forward, and they can apply this as soon as they're done here. So you have to first include your data set. So that's data. And then you use these brackets. And then you call the function order. So here we have order, and a function is always followed by parentheses. And in the parentheses, we're going to include the data frame column, or sorry. So in the function order, we're going to include which column we want to sort by. So I feel like I want to sort by the female column. And then you have to include a comma out here. So the brackets and the comma have to do with matrices, and I'm not going to get into that. Just accept this for now. So, all right. So if I do order parentheses data $ female, comma, this is going to sort our data set based on the female column. And so you can see that in ascending order, so the smallest is at the top and the largest is at the bottom, this data is now sorted. But I actually wanted to know which ones are at the top, not the bottom. I want the most at the top, not at the bottom. To do that, you just add a minus at the top, or at the beginning of your data $ female. So instead of going in ascending order, it's going to go in descending order. And so now you can see that computer and information scientists have the most people in those careers. So yay, all of you out there that work in this field. You're one of many. And then it decreases in order. And then if you wanted to sort based off of two different fields, you can do that too. So if you just press your up arrow, you do minus data $female, and then, so first you want to sort by the females, and then you want to sort by the males. You can do that, and it'll do that for you. And I don't know if it changed much. Yeah, I don't think it changed, but you know, if you have a bigger data set, it might change. So again, we don't see this in the global environment, so we want to save it so we can use it later. So we want to save it as a variable, and we're going to call this our data sorted. And you should do this because we're going to write this data to a file later. So save this. Okay. So if we call data sorted, you have your sorted data set or data file. And you can also do it, I think Carla suggested before. You can click data sorted in the environment and it'll show up over here. All right, great work. We're going to move along and look at some other ways of analyzing data. The next thing we can do is get just a quick glimpse of what the data distribution is. So you can use this function called summary. And it'll tell you some interesting, just like quick stats. So what the minimum is of each column or field, the median, the quartiles, the mean, and the maximum. And you know, you're gonna do your first plot right now, and that's box plot, which is, it's not gonna tell us a lot of information because the data set's not very big, but this is a good way of just looking at your data and maybe making some hypotheses right away from your data. So when you type in box plot parentheses data without any arguments, because we're not going to get into box plots today, we're going to focus on bar plots later. So this isn't going to be a pretty graph, but you can see that the females, the distribution is pretty tight here, and they have, it looks like, fewer people in STEM careers than males, but you know, it looks like there are some outliers, and so I was thinking maybe, or you might also be thinking that there's a couple specific career paths that are skewing this data, but we could find out more. But before we do find out more, these numbers are really hard to look at. You see how they're really, really big and they're facing in a weird direction. So something that we already kind of did with R is use some math on our variables. So I have my data, and these numbers are really big. And what if I wanted to shorten them so that when I plot the graph, they fit in really nice on my graph? So I can divide all of my numbers at once, so my entire data frame, by 100,000. And now I have smaller numbers. So this entire data frame was divided by 100,000. And so this, for me, is like a huge relief, because in Excel, if I want to divide everything by one number, I have to like scroll to the end of time if I have a huge data set to analyze. So I can just type this one command and I'm in the clear. And then all you have to do to store this in or keep this for later, is store this in a new variable. So this is, we're going to call data short. And so when we call data short, we have our shorter version of these numbers. And so if there's any actual statisticians out there, you're going to say, Tess, why are you using this data set for box plots? This is not what you should be doing. And yeah, I'm just using it to demonstrate this is how box plots work. And so when we plot this, so I'm going to go through what all of these different arguments for box plot is. Before, we just had box plot data. And now we have box plot data short. So you can see that the numbers are reduced, but they're still kind of facing in a weird direction. So I want to change the direction of these numbers. And to do that, you can do the following. You can type in this argument LAS, which I have no idea what it stands for, but it changes the direction of your numbers on your box plot. And so when you do that, you can see that these numbers have changed. I'm using my arrow and I realize you probably can't see my arrow. Maybe you can. They've changed. So you can do LAS2, which changes, oh, great, thanks, Alice. Changes them in that direction. LAS3, which changes them in that direction, and LAS4, which doesn't do anything. Oh, I think it's a 0. Sorry, there's LAS0, which is the first one. So it's 0, 1, 2, 3. Okay. All right, so now that we've changed to 1, because that's the direction I like personally, and this is all personal preference, you can label your axes. So you can label your x-axis and your y-axis. And so if I want to label an x-axis, let's say I want to label it sex or gender. I mean, I'm a scientist, so I say sex. I don't know if people say prefer gender. But, and we want to do the y labels. You can say the number of STEM jobs 1 times 10 to the 5th. And now you've labeled your axes. And the last thing you might want to do is put a title on your graph. So to do that, you use the argument main. And you can type in number, oh, don't forget your quotes, number of STEM jobs held by females and males in 2017. I don't know if all that will fit. Oh, it did fit. Okay, great. So now you have a graph. So those are the basics of box plotting, or sorry, plotting in general. And we're not going to save this plot. We're going to come back to it later. Come back to it in bar plots. But I just wanted to introduce you to some concepts, and we'll come back to this. Any questions before we move on? Again, we'll come back to these arguments again in the plot functions, but just wanted to familiarize everybody to that. Okay. All right. So 3.3, calculate statistics. So we're just going to do one statistic, and that's the t-test, because that's the one that, at least in my field, we use pretty frequently. And so again, this data set isn't perfect. There's not a lot of n, there's not a lot of things included in the data set, but just to illustrate a point, when you want to run a t-test, you can use the function t-test, and you will include the 2 things you want to compare. So we want to compare the number of females in career paths in STEM, and and the number of males in the STEM career paths. So we'll do data $ female, comma, data $ male. And it's going to print out a bunch of stuff. So that's kind of overwhelming, perhaps. So this stuff is actually in the form of a different data type called a list, which we won't get into at all, but all to say that you can actually extract all these different pieces. So this is our T statistic, this is our P value, these are the confidence intervals, and there's ways to extract those pieces. But first you need to store your t-test to a new variable. So we'll call that data._t-test. Sorry, if you just do the up arrow, you have that again, so you don't have to type that in. Data_t-test or TT. And so you'll see over here that it tells you, look, this is a list, and you can look at it, and it's kind of scary to look at it in this form too, but I promise it's not scary if you do the following. So you type in data_t-test, and then you can pull up all the different objects in this list. So we have p-value. I want to look at the p-value. So like we were looking at the females and the males before, now I'm pulling out the p-value from this list. So the p-value is very, very, very insignificant, and as we expected. But this is also a really long number. what if, I'm just going to teach you a quick fun function for rounding numbers in R. And you just use this function called round, and you type in what you want to include in that. So we want to do data, data underscore TT p-value. And then that's argument number 1, which is the data you want to round. And then the second argument is digits. And then how many digits do you want to include? Let's say I wanted to include 2. So now it's rounded 0.27 instead of all those digits. And you can change that to 3. You can change that to 0. You can do whatever you want. And again, like I showed you that you can multiply or divide on an entire data set, you can do the rounding on an entire data set. So it's a very powerful and simple function. All right, great job, everybody. We finished everything in this section except for saving these data sets. So in this section, we created 2 new data sets. And we actually have to save them because we're using one of them for the next section. So you have data sorted, which if you print here, was this data where we sorted it by females and then by males in descending order. And then we have data short, and that's when we chopped off a bunch of zeros from our data. So to save a data set, you have to use a function that's similar to when we read it in. Now we're going to do write.csv. So this is how we save a file. So you need to, the first argument it requires is your data set. So we'll do sorted first. And then the second argument that you need is what you want your file to be called. So let's just call it all the same thing so it'll be easier later. You can obviously call your files whatever you want in the future, but this is just so it'll be easy for you to bring it in next time. So I'm going to call it STEM Careers FM sorted.csv. And don't forget the .csv, or it might be problematic later. It might not be super, yeah, it should probably be problematic later. Okay, so there's other arguments you can include. I'm not going to teach you those today, like how you want your data separated later or whatever, but just these are the most basic ways of saving a data set. So that's going to be written to the folder that we're in. So if we go to our folder, you should see, yes, STEM Careers female male sorted.csv. And we're going to do the same thing for the data underscore short. So we're going to save, I'm going to cheat and just do this. So we have first argument, data underscore short. Second argument is what the file's name is. And make sure you use the quotes and .csv. Okay, so now we have both of those files in our directory or our folder on our desktop. So we finished section 2. Good job, everybody. Okay, let's return to our, sorry, we finished step 3. Now we're going to the final step, which is the funnest one, which is where you get to visualize your data, the bar plots that we're going to make. So we're going to use, we're going to learn useful R functions, create bar plots, learn how to add legends, and then create a script and save our bar plots. Anybody not able to save their files? If you don't have your file saved, I can upload it really quick to the, hopefully you did. Please say something if you don't have your file saved. Okay. No one said anything. Okay. So let's return to R. Let's go back to the open folder. And now we're going to open R Ladies for Beginners bar plots. All right, you should look familiar. It should start to feel like, oh yeah, I can look at R scripts. This is great. I'm great at this. Go me. Alrighty, so we are going to first learn some useful, well, basically just one very useful function that has saved me a lot of time and headaches. So first we need to read in our new file. So we're going to call it data_short, and that's our new file, which is the STEM Careers FM short. So we're going to save it to data short equals read.csv. And then if you type the arrow, it's going to give you different options. So you don't actually have to type in everything. So we want the short one. And then you're going to give those two arguments again. So row names equals 1 and header equals true. So data short looks like this. And if you're paying attention, you can remember that we didn't actually have to do that because we already saved it as data short, so it doesn't really matter. And this is wrong. That's an error. I'm sorry. Okay. Alrighty. So the function that I wanted to teach you real quick is called transform, and it's just this very, very almost unnoticeable T. And if you type it with data short, it's going to turn the orientation of your data set. So now our row names are our column names, and our column names are our row names. And this is important for bar plots because the way that the bar plot function reads your data set isn't the way that the box plot function, it needs to be transformed. So you need to do that. But it obviously can't do it on just this command. We have to save it to a variable. So press the up arrow and save it data_short_t equals that. And so if you look at it, you can see, look, my Excel that would have needed me to copy and then paste special check transpose is now transposed with just one little command. It's very helpful. Saved me a lot of time in my life. I think it does have a limit, but for what we're doing and what most people will do, it's very workable. Okay, so bar plots. R is magic. Yay, Carla. R is magic. Bar plots. So like with box plot before, you can just type bar plot data_short_t. So bar plot data short t. So first impression, yay, it worked. I didn't get an error. Second impression, look at that x-axis. And then like it looks kind of cool, but I actually want to see the females and the males separated, not smashed on top of each other. So you might, it's kind of counterintuitive to me personally, because I would have assumed that the default would be to put them side by side and then you'd have to add them on top of each other, but it's actually the other way around. So don't worry about any of that. I'm going to walk you through all the different arguments you need to make this bar plot look pretty. So we'll go step by step like we did with the box plot. So first, do your up arrow, and then add a comma, and then we're going to include the argument besides equals true instead of besides equals false, which is the default. Blah. What is that? What? Hey. Happened. Oh, thank you. Oh my gosh, like everything is ruined. And look, I even typed it incorrectly here. Thank you so much. This is a great moment to say that you'll have bugs all the time and you'll always find yourself needing to figure out what you typed wrong. So it's always nice to have another pair of eyes. Yep. Thanks, Jesse. And Chun. Yeah, it's always good to have another pair of eyes because something might not be working and then you've looked at it for hours and days. And then if you just ask a friend, they can be like, oh yeah, you spelled that wrong. Like, oh, okay. Yes, definitely hard to debug. Okay, so bar plot equals, so bar plot, we have two arguments so far. We've put our females and males side by side, and now we want to change the direction of our axes because I feel that way. So we're gonna do ls equals, actually 1. I'm gonna keep it at 1. Or change it to 1 because I just like the way. So before I think it was 0. I don't know what it was before, but we're going to change it to 1. Okay. I'll change that. Alrighty. So now this is nice and oriented, but this is kind of messy. But we'll come back to that. And then you're going to do sex.axis, and that's the font size of our axes, which we haven't actually included yet. And that's 1 is just like the baseline. But we'll just add that. And then the names is the font size of the x-axis, not the x-axis. And again, haven't shown that yet, but I'll show that now. So now we want to label our axes. To do that, you can use these fun arguments called xlab and ylab. So xlab is, name it whatever you want. So we're going to do STEM, career, and then ylab equals number of jobs 1 times 10 to the 5. Parenthesis. Woo! So now we've labeled it, and that's probably looks familiar from last time. And so yes, as you see, you need to put your labels in quotes anytime you want to print word type things or anything you want to label. And then we'll add some color. So right now the color is gray, is black and gray. We can change that color. We can do red and blue. No, I don't want to do normative colors. Let's do red and purple. Blah, what an ugly color combination. But you can change that to whatever you want later. And then I'll share with you what the so right now you can see that this bar here goes past the 20. That's not helpful visually. So if you want to extend the y-axis, you can use this argument called ylim for y-limit, very creative, and you can do 0 to, let's just do it to 25. So now our axis looks nice. And the last thing I'm going to include here is, again, the main, which is the title. So whatever you want to call it, you can just say, this is very long. No, we'll just say number of STEM jobs held by females, males in 2017. Woohoo! So now we have a graph that has weird colors that fits into our graphical thing here, but this is still a problem. So what are we going to do? Eek, the names of the careers are all messed up. I should just try to shorten them instead. So we can do that by making a vector of shortened versions of these names. So for time, I'm just going to tell you to copy and paste this because it's going to start getting lengthy if you type this all out. But if you can make this vector of names, and then if you save it to a variable, new names, I'll show you how to update our data set to have the columns names go from having the long old names to the new names. So if you remember our data short, the column names of our data short are the different STEM careers. but we want to reassign. And this is where the arrow comes in that someone brought up earlier. Excuse me. So we want to reassign the column names with our new names. And it's very simple to do that. You just do new names, and then you point them to the column names of the data set. And so when you type in call names of data short t, look at that, it's updated. That looks great. So now you can just copy and paste this because it's exactly the same as last time except with prettier colors. So when you copy and paste this, when you run this, you get, ta-da, this beautiful, pretty graph with very complementary colors. Very good. Okay. However, we have no idea what anything actually is. So we might want to add some legends. And so this is the last step we're going to do before saving this file, and then you get to practice on your own. So the first legend is going to be easy. That's just saying that we want our legend to be male and female. So you type in the function. You don't have to like add it onto the box plot. Like in that function, you add it afterwards. So you have your box plot function, and then you put the legend function underneath it. So we start with legend. And then R is cool. You can literally just write where you want it. So we're going to do top left. That's the first argument. Second argument is what you want your legend names to be. So we want them to be females and male. And it needs to be a vector. So that's why we have the C, female, male. And then we need to fill the box with the colors that are on our graph. So we're going to do fill equals C. It's another vector of colors, and just copy and paste it for time. So these are hex values. If you're not familiar with hex, they're awesome because you can pick any color ever in the world and just play around with these numbers and letters until you get like slightly different colors and other colors. And I'll show you in a second the website that I use to find my favorite color combinations. It's Color Brewer 2. If anybody else has any other ones, please share them in the chat. I'd love to learn other color combo magicnesses to include in my graphs in the future. And the last thing we want to add is the sex, the sex, which is, I know it sounds silly, but CEX, which is the size of our legend. So we want it to be not the full size that it will be, but 80% of that size, so 0.8. And then when we do that, it's going to go to the top left, and we have the color, female, male. Woohoo! And this last part, it would take you a long time to type this, so please just copy and paste. But we have to, for the second legend, which is talking about what all of these actually mean, we're gonna have it say names 2 equals what they all mean, and then add it to the top right. So now that you understand how the legends work, just highlight this and run it, and it's gonna print over here. So we have bio stands for biological or life sciences, etc. Okay, great. So now that you have this beautiful graph, which shows that computer science has the most careers, but a huge disparity in those careers, same with engineering, we're going to save that to, oh great, Jake has a package to help you with colors. Thank you, Jake and Alice. We're going to save this to a file. So to save a bar plot to a file or any sort of plot, and if, let's say you want to save it as a PDF, you can save it in different formats, but we're going to do PDF. So you first type PDF, that's the function. And then you just type what you want it to be called. So I want to call it STEM Careers Short. And then you have to include what type of file it is. So PDF. Okay, that's step 1. Step 2 is just copy and paste this part, which is the graph that you already made, so we don't have to type it all out. And then step 3, and don't forget step 3 or you won't actually get anything. You have to include this dev off, and that just closes out the graph. And so when you go to your folder here, you'll see your graph. Hooray! Good job, you did that. Very proud of you. And you can see here, yay! I used colorbrewer2.org to get my colors, and so I just copied and pasted them into my color. And Alice included a link to other color options, but for ColorBrewer2, you can just go over here and you can go look at sequential, diverging, qualitative colors. And then you can also, there's a cool thing for colorblind safe. There's all these different variations, and I just really like them because the colors are really pretty. Cool. So this is the final. So you did it. You made a graph, and now I'm going to have you make your own, all on your own, and that's what the last step of this experience is. So we're going to open the file. This last file, cs_demographics.csv, that you saved already. And you're gonna store it in a variable of your choosing. And then, well, here it's stored. I stored it as cs_dem, but when you box plot it, you can see, oh, and you can include that you don't have to save a new variable that is transposed. You can actually just link different functions on functions. So here I'm transposing this data set. If you remember this, oh, this is a new data set that we haven't looked at yet. So this is all the different ethnicities and races of the computer scientists for females and males. And if you transpose the data within the data, then you don't have to save it to another file. So you just do bar plot that, and you see your bar plot, but look how messy that is. So what your job is going to be to, 1, open your own R script. So you go to this +sign R script. Oops, we don't want that. And so it'll just be this blank space, and you're gonna copy and paste this stuff into that R script. Well, everything here. So this is your first R script. This will be your very own thing, and you can file save this, save as whatever you want to do it. My R script. And so I want you to take, I mean, I don't know if we might want to do questions first before you work on it, but in the end, I want it to look, it should look something like this. This is the goal, is to show the males and the females and males at each demographic, each ethnicity or race, and the number of jobs that they hold, to highlight the disparities within sex and race and ethnicity for computer scientists. So I am happy to, I would love for you guys to work on this while I'm here so you can ask questions, but I'll defer to the team to see if we want to go to Q&A first. So maybe someone could just unmute themselves and let me know what they think.
I don't know that I have a big preference. I think we could do questions now if people have questions that they've been, it's a good time. Anything you've wanted to ask, all questions are welcome, big, small, whatever. And then maybe go to that activity. And then I guess if people have questions, they can still add them later to the chat.
Yeah, and Carla just said something really helpful, which was, well, thank you, that I'm doing a great job with my commenting. It took a lot. It takes a lot to remember to do it yourself. But yeah, if you have comments to remind yourself things as you go, like, oh yeah, this is the thing that I need to do this thing, like type that in as you go, because as Carla astutely pointed out, months later, when you look over your code again, you won't remember what you did or why. And this is very true. Yeah, if anyone has questions, I don't know if that's, is this where the questions are going in this chat? Or do you have a Q&A section somewhere else? Oh, yes.
No, we've just been using the chat.
Gotcha.
We don't have the fancy Q&A feature of Zoom.
Yeah, no, I know that's like, is that the upgraded version?
Yeah, it costs extra.
Oh my gosh, yeah. Yeah, so I would love for you guys to work on this, to see if you have any pitfalls as you go, and then you can ask the questions. So if you want to do that in the next 10 to 15 minutes, and then you can just ask questions as you go, I am here to answer them to the best of my abilities.
Yeah, awesome. I think if people have questions, other questions as well, general questions, anything that, this is a good time to ask, since it's a, kind of like an office hours. Even if people have questions, anything that they've been dying to ask, feel free.
I'm gonna unshare just so I can try to find my camera, but I will come back in a second. There's me. Nope, can't find the camera. That's fine.
Tess, can you see the chat? There's a new question for you.
Oh, great. No, I had to pull it back up. Hold on a second. La la la. Yay! If you ever override your variable, is there a way to undo that? Dun dun dun. No, not to my knowledge. Does anybody else have any thing more helpful to add? No, it's basically gone. So you need to be really careful. Unfortunately.
Yeah, I think that's the great part about, I think when a lot of people get started, you just end up typing in commands into the console. And so that's why starting with writing a script is so useful, because if you overwrite something, you can always go back and start over and you have all the steps.
Yes, that is a great point. Right, so now once you write your code to make your race and ethnicity disparities graph for computer science, you will have that. And if you save your data underscore short to a different piece of information, you can always come back to it, like you were just saying. Sorry to completely reiterate what you said, but thank you for saying that. That's where saving code is good. Yes, rerun the code. Yeah, thanks all of you for coming. I'm glad you enjoyed this. I basically, I hope it was helpful. 1, 2, I hope you make the second graph and you share it with me. My email's up the front, so please email it to me or tweet it at me. I would love to see it. And I over prepared for this presentation, so I have line graphs showing the changes in CS careers for males and females over time, and stratified by race and ethnicity, as well as age and plots about age and salary. And so I might follow up with some more data for you to add to this folder that you guys can play with. So thanks for coming. It's nice to have an audience, even if I can't see you. Yeah, tweet your graphs. Tweet your graphs. We gotta change the number of females and people of color that work in computer science so that it's more equitable and more perspectives. There's a book that just came out about I think the bias behind artificial intelligence and all sorts of computer programming. And so having more people from different experiences and backgrounds involved in those decision-making parts is going to just help the world overall. So, you know, first thing we have to do is see where the problems are, and then we can address them. Wait, is that a book or is that just a statement, Jean? Because it sounds cool as a statement. Oh, okay, cool. Is that the book? I feel like is that what I'm thinking of? My goodness, why can't I find it? I'm sorry, it's just too stressful right now. Yay, that's exciting. I'm glad there's lots out there. So good to read books and recreating data, because there's a lot of data out there that might be correct, and then might look good, and then I don't know, from science perspective, for the methods, you know, there's just not enough information sometimes to recreate what you see. So I was having fun using some of the data that was out there. Oh, yeah, sorry, Jesse, I didn't see your question. Oh, and Chun just added something too. I'll share the data set. It's this. I should have referenced it, I'm sorry. I had all these tabs open and then my computer crashed, so then I didn't save it. So it's in here. Yeah, this is it. So this is where I got all the data from. Here, I'll share this. Woo, thanks, Jerome. Okay. So the data that I used came from the employment section of this this report. So you can just literally download Excel spreadsheets of all of this information. And I did a little bit of, filtering to get the data sets that I wanted. But yeah, there's a lot in there, and feel free to use it at your will. Open source data is the best kind of data. I approve. Oh. Does anybody have a plot? Oh, Alice is trying to.
I don't think I'm going to make it in time. I will say, I guess, before we wrap, I know we have a few more minutes. I do want to just say a big thank you again to Jinyi and Tess for donating their time to prepare these materials and share them with us. And we'll be posting links to the materials again. We can post them on our Twitter and on the meetup page. And so if you want to support Tess and Jinyi, you can follow them on Twitter, retweet them, send them any kind of follow-up questions and everything. So again, thank you. And if there's anything else you want to plug, Tess or Jinyi, feel free to add in any other, things you want to support or plug.
be kind and, you know, do the right thing. I have nothing else to plug at this moment. I'm a little caught off guard. Feel free to chime in there.
Sorry for no warning.
It's okay. I should prepare like a plug statement. This is helpful for future reference. Where do I add this? I'll add this. And yeah, I'll share these slides. I'll add the slide to that GitHub section that I shared with you guys earlier once this is over. Oh, yay. Alice is adding all of these wonderful resources for moving forward. So now that you know the basics, what do you do next? I really want to copy paste this into here. Oh, no.
Yeah, it won't let you copy paste.
Darn. So, you know, this was a complete intro, and there's just so much more, as you heard from our first speaker. There's so much you can do with R, and these resources that Alice just shared are great next steps for continuing. And I know did you include like data, like Coursera and data camp and stuff? There's that as well. Oh, yeah, can't copy paste. Darn. Oh, okay. Thanks, Sarah. I'll add them real quick. Hold on. So it's here. And so it's the same spot where the files were from the beginning. And I'm just going to add it to that same directory in GitHub. Yay! Thanks, Sarah. Wish I could see everyone's faces. Sad. One day we can all meet, hopefully, with masks on. Is everybody staying at home for a while or going back to work? Work from home. Yeah. Yeah. Wow, a few more months. Thanks, Chen. I hope it was exhaustive enough to get the point across. Bye, Danielle. Thanks, Jean. Yay! Thanks, Natalie. Go for it. Overlapping Zooms is such a thing, so I completely appreciate that. But make sure you share your graph with me. I'd love to see it. Ooh, I really wanted to know the answer to this. What is the maximum number of Zoom calls you've been on at the same time? I think I've been on 3 at once. It's a whole new world for multitasking. Yeah, I probably shouldn't have started with like the most crazy value. I should have just been like, maybe 1.5. Oh yeah, you have to have 2 different Zoom accounts. So I have one on my phone and then I have one on my computer. And then I had also logged in through a different, like, you know, some sort of other interface that wasn't Zoom. So you could have them all happening at the same time.
Okay, I think we have 1 minute before 8 p.m. where we will be wrapping up the call. But as I mentioned, if anyone wants to share a graph or anything, please follow up, post it on Twitter. And finally, just another call. If anyone ever wants to present anything, if you want to be one of our speakers or lead a workshop, we are still planning events through the end of the year. We have some great topics already lined up, but we're always looking for volunteers to present. So please do reach out. We have the email address is philly@ourladies.org, but you can also reach out to us on Twitter, or we have a Slack workspace. We do have a website as well, which is just ourladiesphilly.org, where all that contact information is. I'll just remind people that. But thanks again, everybody, for joining, and we hope to see you at a future event.